Hello students, welcome to the class. Today we are going to study a new concept in the surface chemistry chapter, and the concept is colloids. But before we go into the definition and what exactly is this colloid, I would like to remind you about the definition of a solution. So what is a solution? A solution is a homogeneous mixture of solute particles which is uniformly dispersed in a solvent. Now when you see about these solute particles, they are invisible. These solute particles, they are invisible and they do not settle down on when you allow them to stand in a solution. So these solute particles, they are invisible and they do not settle down on when they are allowed to stand. But on the other hand, we have a suspension wherein the particles, they settle down when they are allowed to stand in a solution. Between these two extremes, that is the solution and the suspension, lies another type of system, and that is called as colloidal system, or we simply call them as colloids. So let us see what is the definition of a colloid. So a colloid is a heterogeneous mixture. So a colloid is a heterogeneous mixture consisting of two phases in which the particle size is between 1 to 1000 nanometer. So the particle size ranges between 1 nanometer to 1000 nanometer. Now these colloidal particles, they have certain properties. Unlike your suspension, they do not settle down and they cannot be filtered using a filter paper. Also, many properties of the colloids, they are related, or you find a lot of properties of these colloids because of the large surface area of the dispersed particles. Now, in colloids we study two phases. Okay, so the two phases are, one is a dispersed phase. Now, what is a dispersed phase? A dispersed phase is that phase that consists of finely divided particles, and the second phase that we see is a dispersion medium. So the medium in which the colloidal particles are dispersed, that is called as a dispersion medium. Also the dispersion medium is also called as a continuous phase, and the dispersed phase is also called as discontinuous phase. So what is a dispersed phase? The phase that consists of finely divided particles. Like your colloidal particles are nothing but your dispersed phase, and the dispersion medium, it is that medium in which the colloidal particles are dispersed. Now these colloidal particles are classified based on three types. We are going to study the first type, and the first type is based on the physical state of dispersed phase and dispersion medium. Now depending upon the state of the dispersed phase and dispersion medium, that is, it could be either solid, liquid or gas, these colloids are divided into 8 types. They are classified into 8 types. The first one we will see. The first one is when you have the dispersed phase as a solid and the dispersion phase also, dispersion medium also as a solid. So when a dispersed phase is solid and the dispersion medium is also solid, then the type of colloid that we get is nothing but a solid sol. Okay, and examples here you can find many examples. Some of the common examples are your gemstones, whatever gemstones we use, and your alloys. So that is an example for solid sol. Coming to the second one, keeping the dispersed phase same, that is keeping the dispersed phase again as the solid and changing the dispersion medium into a liquid, and that type of colloid that we get is called as a sol. Now some examples here that you can quote is the paints that we use, or even muddy water. Another example here for sol can also be the ink that we use in our day-to-day life. The third could be the same dispersed phase, that is solid, and the dispersion medium we are changing it into a gas now, and this type of colloid, it is called as aerosol. Now the examples of aerosol, we again see it into our day-to-day life, that is wherein a solid is dispersed in a gaseous phase, that is a gas which acts as a dispersion medium. Here is nothing but your smoke particles, whatever smoke or dust that we get from the vehicles, from the industries which go into the air, they are nothing but they are the examples for your aerosol. Coming to the fourth, now we are taking the dispersed phase as liquid and the dispersion medium as solid. So liquid is my dispersed phase and solid is my dispersion medium. Then the type of colloid that we result in formation is called as a gel. And very common examples here you can find is, which again we use in while having food, is nothing but your butter. We all are familiar with cheese, wherein we have a liquid as a dispersed phase and solid as a dispersion medium. Also another example could be your jelly chocolates that we eat. The fifth one could be a liquid that is in my dispersed phase and liquid as a dispersion medium, that is liquid in liquid, and we get a type of colloid that is called as emulsion. Now one very common example that I can tell you when I remember about emulsion is the very sweet mayonnaise which we all use during our food. Some other examples could be your milk. Also cosmetic products like creams, shampoos, they are nothing but they are the type of colloid which come under emulsions. Sixth one, that is liquid in gas, wherein liquid is my dispersed phase and gas is the dispersion medium, and the type of colloid that is formed is liquid aerosol. Now this is again which we come across, that is during the winter season, December, January, when we all get up early in the morning, we go for a walk, we encounter with the fog, and that is nothing but an example for liquid aerosol. Coming with to my seventh one, wherein the dispersed phase is gas and the dispersion medium is solid, that is gas in solid, and this type of colloid is called as a solid sol. And some of the examples here could be any pumice stone, foam rubber. Coming to the eighth one and the last one, that is dispersed phase being my gas and dispersion medium being my liquid, and nothing but the type of colloid is called as foam. Now this is again interesting part wherein we use in our day-to-day life, that is we use whipped cream for preparing our cakes, or we use even shaving creams. So these are the examples for the type of colloid foam. Now out of all of these, the most common sols that we see in our day-to-day lives are the solid in liquid, that is sols, gels and emulsions. These three are the common colloids that we see in our day-to-day life. Now this is the first type of classification that we have seen, which is based on physical state of dispersed phase and dispersion medium. The next concept or the next classification that we are going to study about the colloids is based on the interaction between the dispersed phase and the dispersion medium. Now based on this interaction between the two, that is the dispersed phase and dispersed medium, here the colloids are divided into two types. One is the lyophilic sols and the second one is called as a lyophobic sols. Now let us try to understand both of them by comparing them with one another. But before that, let us try to understand what is a lyophilic sol and what is a lyophobic sol. So lyo means liquid and philic means loving. So lyophilic sol is one which has love towards the liquid or the solvent, whereas lyophobic, lyo means again your liquid or solvent and phobic means hating. So it hates the solvent, it has no affinity for the solvent. So lyophobic sol is one which loves the solvent or which has affinity for water, whereas lyophobic is one which hates the solvent or is water repellent. Now let us try to compare both of these and study. The first point here is that lyophilic salts, they have strong affinity, meaning that the dispersed phase and the dispersion medium here, they have a very strong interaction. The force of attraction between the dispersed phase and dispersion medium is very high. But when we come towards a lyophobic salt, it says that they have low affinity, meaning that the interaction between the dispersed phase and dispersion medium is very low. The force of attraction between the two is very less. Coming to the second point is lyophilic salts, they are directly prepared. Like for example, when you take any substance and you just mix it with a dispersion medium or with any suitable liquid or a solvent, your lyophilic salts are immediately prepared. They can be directly prepared. You need not take a lot of trouble to prepare your lyophilic salts. Just take the substance, take it in a suitable solvent, shake them well, and your lyophilic salt is prepared. Whereas lyophobic salts, when we talk about lyophobic salts, you just cannot take a substance, mix it with a solvent and shake. No, there the salt is not formed. In lyophobic salts, we have special preparation methods. Those methods we will be studying shortly, but remember that these are prepared by indirect methods. They cannot be prepared directly. Coming to the third point of difference or comparison between the two, these are also called as intrinsic colloids, that is lyophilic salts, they are also called as intrinsic colloids. Now why they are called as intrinsic colloids? Now this depends on your first point, that is they have a strong affinity. Since the dispersed phase and the dispersion medium have a great attraction between each other, therefore these salts, that is lyophilic salts, they are also called as intrinsic colloids. Whereas lyophobic salts, they are called as extrinsic colloids, because the substances over here, when we prepare a colloid, the dispersed phase and the dispersion medium, they do not have a good attraction between each other. They have a low affinity towards each other, therefore they are stated as extrinsic colloids. The fourth one is again related to your second point, that is lyophilic salts can be easily prepared, whereas lyophobic salts are difficult to prepare. Next point is lyophilic salts are stable in nature. Now these colloids that are formed, they cannot be precipitated or coagulated easily. Also they are very stable in nature. Whereas when we talk about lyophobic salts, they are unstable. They are unstable in nature. Now why they are unstable in nature is because they can be easily coagulated. That is, there is a easier formation of precipitation in your lyophobic salts. Coming to the sixth point, lyophilic salts are also called as reversible salts. Now why they are called as reversible salts? Now one example, a very interesting example that I can give you here is at home when your mother takes buttermilk and she keeps it in the fridge. Imagine the buttermilk is in a transparent glass and it is kept in the fridge. Now you come and you open the fridge after some 3 to 4 hours. What you see is that the solid particles, they are collected at the bottom and the upper part is completely transparent. And then you will wonder why is this happening. At that moment what you can do is just take a spoon and stir it well and the entire solution will be constant. Then you can understand that it is reversible. Whatever the particles that are collected or suspended at the bottom, immediately when you shake it, you will get back your colloid. Or I can also state this here is that when a dispersed phase or a dispersion medium, if they are separated from each other and if I want to get my colloid back, if I want to get my colloidal solution back, what I can do is just add some more dispersion, that is just add some more solvent, shake it well and you will get back your colloidal solution. So the best example that you can remember for this is a buttermilk example. Whereas my lyophobic salts, they are irreversible in nature, meaning that since these are easily coagulated, they are easily prepared, easily precipitated. Once the precipitate is formed, you cannot get back your colloidal solution. It is not easier just by shaking that you get your colloidal solution. So thus they are stated as irreversible salts, whereas my lyophilic salts, they are reversible salts. If you just shake the container with the solvent or the dispersion medium, you will get back your colloidal solution. Coming to the last point, that is the examples. Very good examples that I can give you for lyophilic salts are like starch, gum, gelatin, etc. Whereas in lyophobic salts we study about any metals or their sulfides. Now coming to the next classification, this classification is based on the particles of dispersed phase. Okay, now you may wonder why here the classification is divided into 3 types. Now we know the colloidal range is from 1 nanometer to 1000 nanometer. So whatever colloids that we prepare, they should lie in this particular range, that is 1 nanometer to 1000 nanometer. In this we have the first one, that is the multimolecular colloids. Now multimolecular colloids are formed by aggregation of various small atoms or molecules. So when many atoms or many small molecules, when they come together, they form a multimolecular colloid. Like for example, I have these particular atoms or molecules. Now these are very small in size. Their size is less than the range of the colloid. Therefore, if I want these particles to form a colloid, what is going to happen? These molecules, they are going to combine together and form one particular particle, and that is nothing but your colloid. Okay, so standard examples over here that we see is gold sol. Now this gold sol is formed by various atoms of different sizes. Another example is sulfur sol, is also a very common example for your multimolecular colloids. Now coming next to your macromolecular colloids. Now the word macromolecular itself suggests that the molecule is large in size. So its size could be or it will be in the range of 1 nanometer to 1000 nanometer. Thus, how are we going to form a macromolecular colloid? You are just going to take this substance or this particle, you are going to take it in a particular solvent or a liquid, shake it well, and your colloid is ready. Okay. So these macromolecular colloids, they don't require much preparation because they are already large in size. Their size exists in the range of the colloid. So you just take a suitable solvent, mix it with them, and your colloid is ready. Now these macromolecular colloids, they resemble to your true solutions. True solutions. Also another point is we can have here examples like proteins, enzymes, cellulose, and many more. Coming to the last one, that is your associated colloids. Now what is an associated colloids? One of the best example for an associated colloid is soap and detergent. Okay, but how are these formed? So in associated colloids, we can define them like this. When substances are taken in a dispersion medium, and when they are taken in any dispersion medium, they initially behave as normal strong electrolytes when they are at a lower concentration. But as we increase the concentration, they start showing a colloidal behavior, and that results into the formation of associated colloids. So the particles that are involved, they are called as micelles. Now these are also called as micelles. You have to remember this. Now for the formation of micelles, you require a large number of molecules. Like around 100 molecules are involved in the formation of one micelle. Now there are certain conditions that we require for formation of these associated colloids. One condition is that it happens at a particular temperature or above a particular temperature, and that temperature is called as Kraft temperature. That temperature is called as Kraft temperature. Also, this associated colloids, they are formed at a particular concentration or above that particular concentration, and that concentration is called as CMC, that is critical micelle concentration. It is called as critical micelle concentration. Further, we will check the mechanism of micelle formation. The next concept that we are going to see is the mechanism of micelle formation. Now so far you have understood how micelles are formed. We will just check the mechanism for it. Now one of the good example that I can give you for the micelle formation is soap. So soap is nothing but it is a stearic acid. The formula for stearic acid is C17H35COOH. But by nature, what are our soaps? Our soaps are nothing but they are sodium or potassium salts of long chain fatty acids, right? That is nothing but it is in the form of RCO minus Na plus or RCOO minus K plus, right? Now when this soap is dissolved in water, it is going to split up into two parts. One is my RCO minus and then this is my Na plus, right? So the RCO minus is further, it is having two parts. So one part is a hydrocarbon chain that you all can see. This is my hydrocarbon chain. Okay, so this is my hydrocarbon chain. Now always remember, hydrocarbons, they do not have affinity for water. Since they do not have any affinity for water, this is called as hydrophobic tail. Hydrophobic tail. Why tail? Because it is towards the end, so I say that this part is my hydrophobic tail. The hydrocarbon part is my non-polar part, or it is a hydrophobic tail. And towards the beginning over here, I have my hydrophilic part. So this is my hydrophilic head. Okay, so this is the basic thing that you need to know. One is the non-polar or the hydrophobic part, and the second one is the polar or the hydrophilic head. Fine. Now I have, these are my soap molecules. Okay, initially they all are alone in this container. This container is nothing but it consists of your water. So this container is filled with water, and these are my your soap molecules, right? So initially the concentration is less. So at a lower concentration, this soap molecule is in the water in such a way that the hydrophilic part is in the water, whereas the hydrocarbon part, it is away from the water. So you can see the hydrophilic part is in the water, whereas the hydrophilic part, it is away from the water. Now what happens when this concentration reaches a critical micelle concentration? Now we all know that associated colloids form a micelle only when the concentration is at CMC or it should be above CMC. right? So when it reaches at CMC or above CMC, what is going to happen? These anions, they all are going to come together. Now there is not going to be just one molecule of soap or two molecules of soap, right? We have studied that micelle requires at least around some 100 molecules. So these all anions, they are going to come together. They all are going to come together and they are going to form a sphere. Now as they form a sphere, always remember the hydrocarbon part is going to be at the center of the sphere. The hydrocarbon part is going to be at the center of the sphere, whereas my anions or the hydrophilic part, it is going to be at the surface of the sphere. So I told you at the beginning that the hydrocarbon part is nothing but the hydrophobic tail. It is also called as hydrophobic tail. So when an ionic micelle is formed, the anions, they come together, they form a sphere, and the hydrocarbon part is at the center of the sphere, whereas the anions, that is the stearate ions or the hydrophilic part, it is at the surface of the sphere. And this I can call that it is a formation of ionic micelle. Okay, now next we will go for the cleansing action of soap. Cleansing action of soap. Okay, now imagine I have dressed well and I am going out for a lunch. I go for lunch and while having food, I drop some oil on my dress. Now it is but obvious that I am not going to keep that dress just like that, right? I am going to come home, take a bucket of water, add some soap or detergent, and I am going to put the dress into that water. Now what happens? Just look over here. So this is my piece of cloth. On this piece of cloth, some oil has been collected. So this is my oil. Okay, so when this particular cloth, it goes into the water of soap. Okay, so now these soap molecules, they form a micelle around this oil droplet, right? Now before we go ahead, always remember this oil is nothing but it is a hydrocarbon, right? Hydrocarbon. So what is going to happen? This is my oil drop. Okay, this part is my oil drop, this is the surface of the oil drop. Okay, so I know that oil is a hydrocarbon, like always attracts the like, right? So here in the formation of micelle, we have the hydrocarbon tail which is at the inside of the surface, and the stearate ions they are at the outer area of the sphere. Right. So now my hydrophobic part, where is it going to go? It is going to go into the oil droplet. So this is my hydrocarbon part which is in the oil droplet, and the hydrophilic part is going to be at the outside, or it is going to project out of this oil droplet. Okay, now once this soap molecule, it forms micelles with the oil droplet, next what happens is this polar part. Now this is my hydrophilic part. So the hydrophilic part is going to do what? It is going to interact with the water. As there is an interaction between water and the polar part, consequently this oil droplet is also pulled into the water, and thus the oil is removed from the cloth. Okay, so this is the cleansing action of the soap. How are we going to clean a cloth when it is when there is some oil droplets or when there is some grease droplet over it? Now the next section that we will be studying is preparation of colloids.